have a pencil, have some highlighters, maybe have a protractor, and let's get into it. In this one, this is the getting started section, and it talks about how a quadrilateral is either convex or concave. Some real like science terms, I think, actually. Like, remember like lenses, you know, we talked about like earth science and physical science being convex or being concave. I don't know what those hand signals were, but there they are. Convex, concave, two vocab words for us to know. The quadrilaterals you are most familiar with are trapezoids, parallelograms, rectangles, rhombi, and squares. And they're convex, which means that they pop out. Okay? When a polygon is convex, it contains all of the line segments connecting any pair of points. Dude, these include diagonals. And if it's concave, then that means at least one of the angles is greater than 180 degrees. So like less than 180, 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 way more than 180, like almost like a 225 degree angle. Okay, so if we're going to draw diagonals in the two quadrilaterals that are shown, right, consider them shown, we are going to draw a diagonal that goes from opposite corner to opposite corner. So this right here is a diagonal. And then this right here across here is a diagonal. They're both inside the shape. To actually draw diagonals for the other one, for the concave, see it makes a cave right there, then we're going to connect opposite corners. So here's two opposite corners. That diagonal goes through the shape. But if you connect these opposite corners, I know, it's weird, but they're opposite corners. That diagonal has to go outside. This just makes me feel gross. Like, this is like, ew. When, ugh, I don't like it. I don't like the fact that the diagonal went outside. Okay? Don't meme that. Let's go forward. The diagonals of a convex, they intersect. We can actually see that the two diagonals of a convex polygon, this convex quadrilateral, they meet, they actually cross. But these two, they don't cross. The diagonals of a concave quadrilateral don't cross. The diagonals of a concave quadrilateral do not cross. Okay, make a conjecture. I actually just did. All right, so I should have wrote this down there, number 2. Time saver. Let's go to number 3. Oh, you're probably like writing it right now, aren't you? And I'm moving the camera. Deal with it. The diagonals of a, you can always pause the video, rewind, move forward, skip ahead. Please do that. The diagonals of a concave quadrilateral do not cross. Then also, conversely, maybe, the diagonals, or relatedly, the diagonals of a convex. I hope I said concave that last time. Go back and check the tape. The diagonals of a convex quadrilateral intersect. Okay, last part here, to wrap this up. The diagonals of any convex quadrilateral create 2 pairs of vertical angles and 4 linear pairs of angles. Label the vertices of a convex polygon, of a convex quadrilateral, as well as the point of intersection of the diagonal. So here we go. I'm going to try to set this up with a redraw with a little bit larger down here. I know that it's not mentioned, but we just need a random convex quadrilateral. So there. Not trying to draw it like a parallelogram, not trying to draw a trapezoid, just draw a random 4-sided shape, label the corners A, B, C, D. Got it? Now, we're going to draw in the diagonals. So the diagonals, that's what we're talking about, the diagonals are going to be going across from A to C, from B to D. Okay, that means we've created an angle. Let's say they meet here in the middle at E, right? Use the alphabet. So point E is where they cross. And we've created vertical angles because they're across from each other. Get some highlight that match. Vertical angle, vertical angle. And then we've created another pair of vertical angles. So use 2 arcs. Those are vertical angles, so we should name them. The pair of vertical angles that we should name is angle AED and angle, so AED is yellow, so angle BEC also yellow, angle DEC, Notice that all of these have E as the middle letter, and that's pink. So angle BEA, those are the vertical angles. Can you think about what the linear pairs would be? I'll give you one of them, all right? So a linear pair would be the angle that goes from here to here. That's a linear pair. So angle AEB and angle BEC is the first linear pair. Find the other three. Thanks for watching this video. See you in the next one. Bye.